Hi, today we're going to be talking about functions. What is a function? The definitive answer. Have you ever had a friend who, when a question comes up, they know the answer. There's just no doubt in their mind. Like perhaps, who is the greatest NFL quarterback of all time? And their answer is, it's Tom Brady. There's no doubt about it. There's no question. He won the most Super Bowls. He is the greatest NFL quarterback. But you might have another friend who is willing to play devil's advocate. What about Peyton Manning and his regular season record, or Brett Favre and his many years without missing a game? Who is the greatest quarterback? If they kind of create multiple answers, this is not what I'm calling definitive. A function is like the first friend. For any question or any input, there is a definitive output. And there's no question about it. Functions have that quality. There is an input, and then there is an output. Not multiple outputs, not undefined. There's a group of operations that take you from this input to that output. Now the input, the set of things that we're putting in, we call that the domain. And the set of things that come out, we call the range. Let's look at this abstract example. Some people call this a correspondence or a relation. When we draw these little arrows, we're relating these names on the left to these dates on the right. Now, if you look, this relation does have some definitive answers. Brian definitively is associated with February 5th. Perhaps these dates are, when did this student take the ACT? Maybe they're filling out an application for college. Now, so Brian took the ACT on February 5th. David took the ACT on January 17th. Those are definitive answers. But we would say that this thing is not a function because of the Katie example. If you look at Katie, she is associated with 3 different dates. She took the ACT on February 5th. She took it on August 7th, and she took it on December 20th. So this is not definitive about that particular input. Another problem with this function, with this relation, is Michelle. Michelle is undefined. She is not associated with any particular date. So a function is both defined for everything in its domain, and it doesn't have multiple outputs. Let me change it up a little bit here. Let's make it definitive about Katie and definitive about Michelle. So Brian is still taking the ACT on February 5th, David's taking it on the 17th, and Katie is taking it on August 7th. Michelle now is defined in taking it on August 7th. So we would say this is a function. This is a function because it's definitive for each input. For each input in the domain, we call this first list the domain, and the second list we call the range, the output. And this is a function in this abstract sense. These two relations, so they're ordered pairs. You have an input and an output. If it helps, sometimes people like to do a little t-chart. An X and a Y. For this first example, the inputs are 9 takes you to -5. A 9 takes you to a +5, and a 2 takes you to a 4. Now, if this looks a little strange to you, like these two 9s, it's because we're not used to working with non-functions. This thing is not a function. And it's because that 9 has multiple outputs. So here is the problem. So 9 takes you to -5, and 9 takes you to +5. Now let's look at our second example. Again, let's do a t-chart to just relate it back to what we've seen in the past. So our inputs are -2 takes you to 5, +5 takes you to 3, 0 takes you to 5, and 4 takes you to -2. Now this is a function because it is definitive about each of its inputs. Each input has a definitive output. Now, if you look right here, so -2 takes you to 5, 5 takes you to 3, 0 takes you to 5. There's a definitive answer. Now, if you were wondering about these two 5s, duplicate outputs, this is not a problem for a function. The outputs don't have to be unique among all of the range. You can have two different inputs can go to the same output, and it still is a function.